I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
Imagine a war you can't see, where no bullets fly, no tanks roll, yet silently, nations battle across invisible waves of energy. This is the electromagnetic battlefield, and artificial intelligence has become its ultimate strategist. For over a century, militaries have relied on signals intelligence, or SIGINT, to learn what their enemies were doing. Back in World War I, radio operators listened through static and scribbled down intercepted Morse code. Today, the mission has evolved into electronic intelligence, or ELINT, where machines no longer listen to voices, but to radar pulses, missile guidance signals, and other electromagnetic whispers that reveal hidden threats. In this invisible domain, AI-powered ELINT is like having a million digital ears tuned to every frequency on Earth, constantly learning, adapting, and outthinking opponents. These systems can detect radar emissions that change frequencies in microseconds, identify what kind of radar it is, and even predict its next move, all before a human can blink. Modern emitters use tactics like frequency agility, where radar rapidly hops between frequencies to avoid detection, and low probability of intercept waveforms, or LPI signals, which are designed to blend into background noise and remain nearly invisible to sensors. But deep learning models trained on vast signal datasets can recognize these elusive patterns instantly, turning stealthy signals into open books. This is the age of AI-driven electromagnetic maneuver warfare, where the goal isn't just to listen, but to dominate the spectrum itself. By fusing sensor data from aircraft, ships, satellites, and ground stations, AI creates a living digital map of the battlespace, showing who's emitting, who's jamming, and who's hiding. Let's see how that works in action. Modern ELINT receivers can scan enormous frequency ranges in a fraction of a second. Systems like the CRFS-RFY sensors sweep hundreds of gigahertz per second, picking up radar signals that might appear for less than a blink. Once captured, deep learning classifiers, especially convolutional neural networks, analyze the signal's pulse, pattern, and modulation type to determine whether it's a weather radar, a tracking system, or a hostile surface-to-air battery. Cognitive electronic warfare algorithms take it further. By studying how a radar behaves over time, they can predict its next beam position or frequency hop, allowing defenses to preemptively jam or deceive it. That's like predicting an enemy's next chess move before they've even touched the board. When suppression becomes necessary, AI orchestrates a coordinated mix of countermeasures, including jamming, spoofing, and decoys. Digital radio frequency memory, or DRFM, records enemy radar pulses and replays them with minute distortions or delays, tricking radar systems into detecting phantom targets. Spoofing, meanwhile, floods the electromagnetic spectrum with carefully crafted but false signals, creating chaos and confusion within enemy sensors. Completing these, AI-directed decoy drones can replicate the radar signature of actual aircraft or ships, forcing opponents to waste critical missiles on illusions rather than real threats. Together, these tactics allow militaries to control perception itself, deciding what the enemy sees and what remains invisible. Countries around the world are racing to master this algorithmic warfare. The United States leads in operational AI ELINT platforms, using machine learning aboard aircraft like the RC-135 Rivet Joint to classify over 500,000 signals per hour. China is rapidly catching up, fusing AI with long-range electronic surveillance systems capable of tracking radar activity across the South China Sea and even the Pacific Islands. And India, through its IDEX and Netra programs, are developing AI-based ELINT constellations and drone swarms for persistent border monitoring, an indigenous approach to securing electromagnetic superiority. On the ground and in the air, AI has already proven its worth. During India's Operation Sindoor in 2025, autonomous drones equipped with neural signal processors intercepted and decoded radar signals hidden in electromagnetic clutter. They built 3D maps of the battlefield in real time and sent that data directly to fighter jets for precision strikes, all in seconds. What used to take hours now happens faster than human reaction time. This is the dawn of machine-speed warfare, where algorithms sense, decide, and act before a commander even gives an order. In 2024, the world saw another breakthrough. Shield AI's HiveMind achieved the first fully autonomous air combat between two drones, coordinating maneuvers, sharing sensor data, and responding to threats without GPS or remote control. It's a glimpse of the future. Intelligent swarms operating as a team, each drone a thinking node in a larger digital organism. And yet, the race is far from over. The next evolution of ELINT will hinge on emerging technologies like the quantum compass, which uses quantum states of atoms for ultra-precise navigation even when GPS is jammed or spoofed. Eichelberg collective detection, which analyzes the coherence of incoming signals to verify whether GPS data is genuine or fake. And metamaterial antennas, engineered surfaces that can electronically reshape themselves to resist jamming and redirect beams instantly. These innovations promise a future where every radar pulse, every signal reflection, and every electromagnetic anomaly can be sensed, decoded, and acted upon at lightning speed. From the trenches of World War I to the satellites of today, electronic intelligence has transformed from manual interception to autonomous digital strategy. The side that controls the spectrum controls the fight. And in tomorrow's wars, that means those who wield AI-powered ELINT will see first, decide fastest, and strike smartest. The battlefield may be invisible, but its consequences will shape the future of global power. Thanks for watching. Subscribe, follow, or visit idsth.com for more cutting-edge defense and tech insights. See you in the next one.